All right, so calculating confidence intervals for two means. So these are the formulas we kind of just talked about, but so you also have them here. Confidence interval is y bar 1 minus y bar 2 plus or minus t star for whatever the degrees of freedom are times the square root of s. Oh, that's nice. Just want to come back to life here, buddy.
At first I was like, wait, is she just talking on the Saturday?
I'll change it to a different color after this so I can brighten the screen back up. But s1 squared over n1 plus s sub 2 squared over n2. And these S values here are the sample standard deviation. Oftentimes, like I said, calculating the degrees of freedom for two samples can be a little tricky. So I would say a lot of times let the calculator find it for you, because it will. And so, kind of use that to find the value if you have that option. But, and then also these are the sample means here. I'm going to brighten this back up just a little bit. So that way I'll just use a darker color instead of the orange. All right, so in terms of checking conditions, we talked about that kind of already, but just written a little bit differently. As far as the independent groups, obviously we said they must be independent. There's no way to, check that mathematically. You kind of just have to think about it. So, it kind of should just make sense, I don't know if it is or isn't. Okay. A man who moves to a new city sees that there are two routes that he could take to work. The man decided to experiment. He flips a coin to determine which way to go. Traveling each route 20 times, he finds that Route A takes an average of 40 minutes with a standard deviation of 3 minutes, and Route B takes an average of 43 minutes with a standard deviation of 2 minutes. So I'm going to underline each one here. And he's doing it 20 times, so that'll be our n value. They tell us that histograms for the routes are roughly symmetric and show no outliers because we need to know that it's nearly normal, and we don't have the ability to actually do that, right? So, find a 95% confidence interval for the difference in the average commuting time for the two routes. So, first of all, as far as our conditions, are our conditions met here? Is it random?
Yeah.
10%? Yeah, it's less than 10% of the times he travels it. Nearly normal? Yes, because he said the stuff about the histogram. Now, are these groups independent?
Are the groups the
Like,
routes?
Yeah, each route. So is
Yeah,
each route independent?
I don't think they affect each other.
Yeah, more than likely not. I mean, obviously, they could have a slight overlap at some point, but that they don't say that, so we're not going to read too much into it. We're going to assume that Route A and Route B are totally different when we're doing this. So we want to find a 95% confidence interval for the difference in the average commuting time of the two commutes. So I can use a 2 sample t interval to do this on the calculator, or I can set it up in writing. So I'm going to set it up first, so we won't actually solve it out that way, but just so you have the setup, and then we'll do the calculator option. So the confidence interval is going to be 43 minus 40 plus or minus Now, the T-star value, I'm just going to write this here because we don't know that number yet. That's why you need to let your calculator find it for you. And then this times the square root of 2 squared over 20 plus 3 squared over 20. And I think it's going to ask you, but don't pull the data when it asks you. So now on the calculator, we set this up as a 2 sample t interval. Of 43, 2 and 20, and then 43 and 20, and not pulled. I think that's the order that it's going to ask you for this stuff in, but I could be wrong, so I should probably pull it up and make sure. Nope, so I can put stat. Stats. And it's the option for stats, not data, because they gave us the information.
Yeah, the order's correct.
Oh wait, it also asks you.
Is it actually?
It also asks you about mute, so that's why I'm reading the problem again.
Oh, it does.
Wait, where's new?
Scroll, push the down.
If you keep
arrow.
scrolling down, it asks.
Oh, I don't have anything about new.
Oh, really?
Yeah.
Mine says like mu is 1 colon
Difference.
not equal to u to mean 2.
Did you do the 2 sample t interval?
I was on test. Oops. I was like, what?
That's what I did too.
Okay. Oh, okay. Oh, is that what it was?
I saw
Oh,
2
you?
sample T and I just clicked it.
Yeah,
That's
me
what I was
too.
like. Okay, well. I feel like we're gonna well, no, I don't think this question's gonna end up asking us that. So, anyways, okay. Well, RIP to that.
And stats. Oh, it still has the same information in though, so that's
Except there's no mu, so you don't have to worry about it.
nice. And then
See, better for it to happen now than. Oh yeah, because it's gonna want the confidence level.
Confidence interval, yeah.
Okay, let me go add that in here.
Oh, and then it asked you if it wants it pulled or not. So no.
There we go. Okay. And then calculate.
So how far up do you want us to go?
I have that in my notes.
I would just go to 2 or 3. It doesn't matter.
1.36, 4.64.
Now, what do you notice the degrees of freedom are for this problem?
33.
And notice that's different than what we would have expected. So that's why it says let your calculator find that for you.
Okay. Because would we expect it to be in 19? Because it's 1 less than n.
I would have either expected 19 or 39. Like those would have been because if you did each root twice. But
Yeah.
obviously notice it's not, and that's why it's good to note that you should.
So you can't really do this by hand?
Not really. You would have to do something first to have figured that out. I'm sure there's a way you can, but I don't know it off the top of my head because I always just use the calculator function.
Yeah.
But I mean, at least the setup of it, like, again, I think you could get an idea of what it is at that point. And I think there might be a way to actually find it without doing all of that, but I'm not sure. All right. A neighbor tells the man.
Sorry.
I was like, what is happening? A neighbor tells the man that route A will average 5 minutes less than route B. Should the man believe the neighbor's claim?
No,
Why?
because 5 isn't in our confidence interval.
Correct. Because is route A faster or slower?
Fast.
Okay. So
Oh, okay.
the answer would be no. Route A is faster, but not 5 minutes faster. And then you could say, I am 95% confident that route A takes an average of 1.36 to what is happening? 4.64 minutes less than route B.
So the numbers we get have to do with like the first thing, like route A.
Well, we actually did B first. B was our one value.
Wait, B was what?
B
Yeah,
was
so how do
actually
we-
1.
Yeah, so how do we determine like what these numbers like mean? Like how do we know that's meaning that route A goes faster?
I think if we were to flip the numbers, we would see that it's negative,
Oh, okay.
and
so
then
that
it would
be
show
route A
us,
that much slower.
yeah.
Okay.
Like, I think it's showing how much longer route B takes in our confidence interval.
Yeah. The first one is longer than.
Okay.
So we're just flipping it to say that A is less. But we could have also said, I'm 95% confident that route B takes that much longer than.
Okay.
Yeah. Yeah. It technically is giving us the stuff for whatever we put into 1.
Okay.
But we wanted to talk about route A, so that's why we flipped it and said less than, even though it would have actually been greater than. And I think if we had done what you and I were doing originally with the t-test, I think we would have seen that as well.
Okay.
But I'm not 100% sure because we obviously didn't get that far. We stopped. Okay.
Are we gonna have to put this on a list?
Yes. 2 lists, actually.
Ooh, I'm gonna get started on those right now.
All right.
Go get them.
So, American League, put in L1. National League, put in L2. And you're going to need a 2 sample T interval for these.
We repeat the ones that are. Will we repeat the ones that are?
Yes.
Okay.
Every time it's there. Because notice, too, there's more, well, you may not be able to tell this, but there's actually more numbers in L1 than L2. Or vice versa. There's more in L2 than L1. There won't be the same amount.
That's
You said what was the function you were reading?
It'll be a 2 sample T interval. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, there's only one difference.
It would really help if I put
Must have added
14
them.
instead of 140.
Can't change anything.
All right, so the actual question says American League Baseball teams play their games with the designated hitter rule, which this problem is no longer a thing, but meaning that pitchers do not bat. The league believes that by replacing the pitcher, traditionally a weak hitter, with another player in the batting order produces more runs and generates more interest among fans. Below are the average number of runs scored in American League and National League stadiums for the first half of the 2001 season. So the first thing actually says to create an appropriate display of these data. What do you think might be a good way to display this data?
We can,
Instagram, perhaps?
That's one option.
Or like the cat and whisker plot thing.
Yes. Do you remember parallel box plots? Okay, so let's look at a parallel box plot because it allows us to compare the two distributions. So go to stat plot. You might want to do the option that would potentially show you. Actually, never mind. It's like option 5 under your thing. And then you'll do it for L1, and then you'll do zoom stat. If you have something in your y equals, you might want to clear that. I do. Then you're going to have to turn the second stat plot on to put the other one on there with it. So
Oh, okay. You said it was the 5th one? On, like, the type of graph?
yeah, it's the one that's like got the box and then it's got the line through it and like this. Yeah. So I'm going to do one for the American League.
Wait, is this supposed to show up with it?
What do you mean?
Wait, I thought you said it was. Wait. Oh, they never turned the plot off. That will do.
Now, your window might need to be adjusted for you to actually see everything. And your window would need to be wider than whatever your min and your max value for the National League is.
So. Okay. Wait.
Now that I changed my window, I need to redraw these.
So what should I change my window to?
I changed mine from like 5 to 15 or something like that on the X value so I could see the whole thing.
The max or the min?
The min was 5 and the max was 15, I think. Because I have 7.9 to 14, so I might have done it a little excessively, but
Oh, okay. Oh,
I just put
I
mine
think
to-
mine's fine.
I just did the zoom stat thing.
but you can't see all of the National League graph if you do that.
I can.
Are you sure?
I don't know now.
I mean, I don't think the calculator lies.
Okay, well, mine didn't, so that's why I was saying that.
wait, how do I add the other one? Do I just make another?
Yeah, you turn another plot on.
Oh, R.I.P. that
Is that
dead
all
one.
of it?
Yes.
Okay.
Yours are just flipped upside. Well,
yeah,
it looks like.
because I did my L2 in the plot one,
Oh.
and then the other one. I can change that a little. I'll just drop it on.
Now, the stat plot for the NL. Go change it to option 4 instead of option 5 under your stat plot. So do it with the ones that have the little dots on it.
You said the one with NL?
Yeah. So like I think for you said that was your L1. For me it's my L2. And notice the difference.
That is very different.
What happened when I chose that one?
Gave us a little dot
Why?
outlier.
An outlier. Okay. Now, 14 isn't all that much bigger than 11.6, but comparatively to everything else, it is a good bit larger. So when I saw that this was very skewed on this side with a lot of extra data, I thought, let me check and see. I don't remember where this fell. This was somewhere in here. Let me check and see what happens if I change it to the one that shows me outliers. And so that one shows me that realistically there's actually an outlier somewhere in here and that this would actually be stopping there. Basically. So, the American League one, what does that one kind of look like?
Kind of
It's fine. I don't know.
Symmetric,
Kind of
yeah.
perfect.
Overall symmetric. Okay, obviously my picture's not great, but
just a little skewed.
symmetric overall. You could say roughly symmetric. How about the National League, though?
Skewed.
Even when I take out the outlier, it still is a little bit, right?
Yeah.
So, slightly skewed right. With an outlier. Always good to point those out when we know that they're there. So since I had two things I needed to compare, it's good to use parallel box plots. Not that we couldn't have used a histogram or something else, but I couldn't see them side by side if I had done it that way, and the increments would have been different. By doing this all in the same graph, it makes it so that I can see everything.
Yeah, I tried the histogram thing and they were on top of each other.
Yeah, so it makes it. Now, if you can do colors, it helps, but when you can't do colors, it makes it a little difficult. So, with a 95% confidence interval, estimate the mean number of runs scored in American League games. So, notice we're doing it specifically for American League. Okay. So, this is back to the last chapter of stuff, really. So, we have our confidence interval. Now, I don't have enough information without running some, one variable stats to actually be able to find all this information, right? So, I can, once we do it on the calculator, we'll go plug in the numbers by hand so you'll see what it would have looked like, but I would have to run one variable stats first to be able to fill in everything that I need. So run a 95% confidence interval just for American League.
So we have to do the variable stats thing?
It should be no, we're just going to do the T interval on the calculator. If we had to do it by hand, we would have to use one variable stats. But at that point, I would just,
Is it T interval or two sample T interval? I mean,
just T interval because we just care about American League. And it's going to be the data one because it's going to have to pull the, whatchamacallit, the numbers. Because I don't have everything filled out, and it's for 95% confidence.
It's stats or data?
It's data.
Yeah.
Data. It's data. It's that one. I wasn't correcting you. I was okay. I promise I wasn't correcting you. I was just.
So this would be a T interval for,
Is this for the, we're doing American.
I don't even know what it asked me for in order, but, huh? Yes.
So it's like data,
I don't. Yeah.
and then like the list
Yeah.
and frequency and confidence.
I think it was something like that. I don't know. Close enough. I didn't write it down before I did it. So then I get 9.34 to 10.27. Now, this provided me, by doing this, my X bar and my standard deviation, and it told me the sample size. So I could actually go through and set this up by hand now as 9.81 plus or minus T star sub 13, because my n value is 14, times 0.81 over the square root of 14, and I would have gotten it that way as well. What concerns do you have about making a similar confidence interval for National League games?
It's super skewed.
So skewed and there's outliers.
It's skewed and there's outliers, yes. And so, because of that, the fact that my sample size is 16, it might not be big enough, right? Because that was where we had that in between, and we're like, it might be okay, it might not be okay, because it's so close to that 15 value that we said, from like that 15 to 40. And so we might want to run it without the outlier, so by removing 14. So outlier, and I'm just going to write what the outlier is, and skewed. So n equals 16, might not be large enough. Possibly run the confidence interval without outliers.